Hi everyone,
Hello everyone,
and
welcome to this video dealing with coordinates and polar graphs.
This is a continuation of
this
the one that I
video
just
picks
asked you
up
to
with
look at
after
this one
what we did
that
in
we saw last year.
pre-calculus when we looked
Anyway.
at polar coordinates and graphing on polar grids. So those are going to be kind of some of the assumed knowledge at this point with this video. And if you haven't had a chance to, you might want to look back at that. I did put a link to that video on Classroom for you, so you can take a look at that. But anyway, the objectives for this particular video is really just recall the conversions between rectangular and polar equations, and the main one here is find the slope of a tangent line to a polar graph. So let's get right to the conversions. Recall now, the first thing I want you to remember on these graphing is that when we worked with polar coordinates, going between rectangular to polar coordinates are always we would use the fact that the tangent of theta is going to be y over x. So if you remember, I wanted to go between rectangular to polar. What I have to identify is I have to identify r and theta. And so I know to go from rectangular to polar, I know the tangent of theta was y over x, and r squared was going to be equal to x squared plus y squared. Now this did cause a little bit of an issue. Well, it didn't cause an issue. You have to, because of the tangent of theta is y over x, and this results in r squared, we do have the possibility of positive, negative r, and also the fact that the angle itself could be in, the point could be in second quadrant or third quadrant, which would mean that the inverse tangent of y over x is not going to give you the specific angle you wanted, unless you were going to use a negative r in those situations. But the other one you have is to go from polar to rectangular, and to go from polar to rectangular. So now we're given this point in r theta. The x coordinate is going to be r cosine theta, and the y coordinate is r sine theta. So now let's assume that we have a graph. We've graphed r equals f of theta, where r is some function of theta. Well, on that graph then, because of our conversions, I know that all the points, the x would be equal to f of theta times the cosine of theta. And I would know y equals f of theta sine theta. Now, what I want you to recognize on this, these here are kind of like parametric equations, aren't they? Where the parameter is theta. So what's going to happen now is that we're going to need to go and find dy dx. And we know, in this case, that dy dx is going to equal dy d theta over dx d theta. So let's take a look at that. So remembering now that in this case we have y equals f of theta times sine of theta, I know dy d theta is going to be where I'm going to use the product rule, f prime of theta sine theta plus f of theta cosine theta. And x is f of theta cosine theta, so dx d theta will be f prime of theta cosine theta minus f of theta sine theta. So therefore, dy dx is going to be f prime of theta sine of theta plus f of theta cosine theta all over f prime of theta cosine theta minus f of theta sine theta. So now what I want to do is look at an example here. We want to find, in this case, we want to find the slope of a tangent line to the graph of r equals 3 minus 2 cosine theta at theta equals pi over 3. So in this case, we know x is going to be 3 minus 2 cosine theta times cosine theta. And I can go through, use the product rule. I used the product rule when I did this. You could go through and distribute the cosine. But ultimately what you end up with is dx d theta is 4 sine theta cosine theta minus 3 sine theta. And the same thing exists here for y. Y is 3 minus 2 cosine theta sine theta. And so again, I used the product rule. If you want, you can distribute it. But when I went through and did that, I came up with dy dx is came out to be 2 sine squared theta plus 3 cosine theta minus 2 cosine squared theta. Now, one thing you might notice as you're working on this is that parts of this, this part right here, 4 sine theta cosine theta, and these two parts, the 2 sine squared theta minus 2 cosine squared theta, those might look familiar to you. One of the things you could remember is that we know the sine of 2 theta is equal to 2 sine theta cosine theta. And I also know that the cosine of 2 theta is equal to cosine squared theta minus sine squared theta. So I could use those to simplify this a little bit. I could say that that this portion right here, this would come out to be 2 sine of 2 theta minus 3 sine theta. And this part, this would then come out using this identity. Notice it's been switched, so it's a negative. It would come out to be negative 2 cosine 2 theta plus 3 cosine theta. Either way works. If you don't recognize it, it's not a problem, but it does come up in terms of just maybe even simplifying some calculations or making the problem a little bit smaller if you recognize it. So over here on this slide right here, when we go through and actually solve it, you'll notice that I did go through and use those changes with the double angle formula. So I calculated dx d theta at x equals pi over 3. It's going to be 2 times the sine of 2 times pi over 3, which would be 2 pi over 3, minus 3 sine of pi over 3, which gives me 2 times the square root of 3 over 2 minus 3 times the square root of 3 over 2, which ultimately will result in that the dx d theta at x equals pi over 3 comes out to be negative square root 3 over 2. dy d theta at x equals pi over 3 comes out to be is negative 2 cosine of 2 pi over 3 plus 3 cosine pi over 3, which comes out to be negative 2 times negative 1/2 plus 3 times 1/2, which gives me 1 plus 3 over 2, which gives me 5 over 2. And so therefore, I know dy dx is going to be 5 over 2 all over negative square root 3 over 2, which results in negative 5 over the square root of 3. And if you wanted to rationalize it, you could say negative 5 square roots of 3 over 3. So the slope of my tangent line when theta was equal to pi over 3 would come out to be negative 5 square root 3 over 3. This now does conclude the video for dealing with the slope of the tangent line. The next video is will deal with the area in a polar curve, as well as the area between polar curves, and also looking at arc length and surface area of a polar graph. So with that, we'll see you later.